Hi everyone, we're doing 16C in Honors Chemistry and we're going to talk about neutralization. A neutralization reaction is when you mix an acid with a base and you come out with a salt and water. When the amount of H plus ions and OH ions from the acid and the base are the same, that's called neutralization. And we can use that fact to find out several things. I put this here because I want to show you what we use for a titration, but you do have a titration lab. Listen to it closely. I'll give you the equations. You can perform the equation with him and you can describe what he's doing, but the definition of titration is right in your book, so you should be able to see. Now, the definition of a salt in chemistry, as I said probably a couple videos ago, is any ionic substance that has a cation that is not H plus and an anion that is not OH minus. So sodium chloride is a salt, magnesium sulfate is a salt. So a salt doesn't necessarily mean table salt. All right, so titration. This equation this is the equation you're going to use for some of the problems in your section reviews and your chapter reviews. I believe this is the only equation that you're going to be using, except for pH plus POH equals 14 and a couple like that. But this is the molarity of the acid you're using times the volume of the acid you used equals the molarity of the base you're using times the volume of the base you're using. And what you're doing in a titration is trying to determine the concentration of something you don't know. We use it when we try to find how much chlorine ions are in Tybee seawater in AP chemistry. So titration is a very useful tool for analysis. Now, let's say in here, in this first burette, see, the reason we use these is because they're marked off, and they're marked off from 0 at the top and they go down. So you can tell how much you've used when you're just putting it in drop by drop. So I usually fill that with 0.1 NaOH, which is a base, okay? This we will get off of here when you finally neutralize it. I don't know what the molarity of the acid is. I'll get an acid and I'll say, gee, I don't know what the molarity is. So let's try hydrochloric acid. That's usually the one we do in Honors Chem. We put hydrochloric acid under there. I'm not sure the molarity, but I put 25 milliliters in there, so I know the volume. Then I put a little bit of phenolphthalein in there because it changes color when it's neutralized. So there are two terms we use here. We use the terms, sorry, I want to make sure. We use the term equivalence point, and that's the point where the H plus equals the OH minus. That means it's completely neutralized. All that's left in that solution is NaCl and water, okay? So that's the equivalence point. The end point is basically almost exactly the same point, but that's where the indicator color changes. So if you're not using a pH meter, which in the AP class we use the pH meter, but if you're just using phenolphthalein, you're putting this in drop by drop because you want to get that exact point. And when you put a drop in there and swirl it around and it turns pink, you're done. If you go and put too much, you don't know when that happened. And you may have put in a milliliter or two too much. So to find out what the molarity is, let's say in this experiment, I use 24 milliliters. So to find out my molarity of HCl, I would put 24 in here, because that's how much I used. And then I would just solve the equation. It's a very simple equation to solve. 0.1 times 24 gives you 2.4. And then you do 2.4 divided by 25, and you get 0.096 is the molarity of the HCl. So that's how you can use a neutralization reaction to solve problems, okay? So if they give you how much acid you have and how much base you used and what the molarity of the base is, you can find the missing part. So this is your equation. Now, remember, the last video, I said if they use the base CaOH2 and they give you the molarity is 0.01, remember, you have to multiply that by the 2. So you're going to plug 0.02 in. If they tell you you're using sulfuric acid, H2SO4, and they tell you the molarity is 0.03, but you have 2 moles of H's for every 1 mole of that, so you have to multiply this, so you have to plug 0.06 in for your molarity. So don't forget, look at the formula for the acid or the base. If it's just 1, then use just the molarity they give you. Okay? So, last but not least is buffers. Buffer, like I said, is a combination of a weak base and its a weak acid and its conjugate base, or a weak base and its conjugate acid. And it is used to buffers are used to try to keep the pH level. For example, in your blood, you don't want it to get too acidic or too basic. So your blood, you can read what exactly it is, what the buffer exactly it is in your book. But if you drink too much something acidic, your blood will actually buffer it out. And they use Le Chatelier's principle to do it. Remember from last chapter, if you add H+, meaning you add some acid, it's going to shift it the other way to reduce that amount of H+. If you drink something too basic, it'll react with the H+ ions and remove them and shift the reaction that way to produce more H+ in order to balance it out that way. So buffers really work using Le Chatelier's principle. All right, I hope this has been helpful, and I will put professional videos up there because obviously these are really second rate. Thank you.